Hi, welcome back. Today we're gonna see a topic of calculus that is called integration by parts. It was created by Brooke Taylor in the 18th century, and it's used to apply to two or more functions. It's not a rule or it's a method that we can use to obtain a final solution. It doesn't establishes that we're gonna get an exact solution, but it's a tool we can use to help us get to the process. We're gonna see the formula that is very simple. It's the integration mark, and then we have the u multiplied by the dv. This is the two elements, and it's gonna be the formula is u multiplied by b. Then we have a minus, and then we have another integration that is gonna be b multiplied by du. Here we're gonna get the final result, and this is gonna be simpler than the first one, so we can get a solution.
Okay, so there's a special trick to learn this formula. It's a Spanish phrase, and here are some drawings about it, and it's called Un día vi una vaca vestida de uniforme. You have to take the first letter of each word, U, D, V, U, V, D, U, and you get this formula. The four main factors are D, DV, DU, and V. So the main ones are U and DV. You're going to derivate U and you get du, and dv you have to integrate it in order to get v. The main point of this technique is to simplify the integral, and there are going to be cases that you get another product and it won't be simpler. So what you have to do is to repeat the process until you get a simple solution and you can integrate it normally.
Hi, remember you have to choose wisely your U and your DV. We have a clue to find the U. It's an anagram that it's called Liate, and it's L for logarithmic, I for inverse, A to algebraic, T for trigonometric functions, and X for exponentials. With this, when you have an example of an integral with two, you have to find or visualize which is first, and when you find that one, that will be your u.
I have here one example, and I have integral of 10x times e2x dx. And the first thing I did, I chose my u, and I chose 10x, and then I derivated, and I got my du, that it's going to be 10 dx. Then I chose my dv, and I got e2x dx, and I integrated, and I got a half of e to 2x. Then I mixed the ingredients I chose, and I got this part is my uv, u times v, and then minus the integral of v times du. Then I simplified it. I got 5x times 2x e to 2x minus 5 e to 2x. I just simplified it. Then I did the integration part. This remained the same, and this is already integrated, and then we can add our c, and we're done.
So we're going to make the second example. This will be our function, x to the 3 times natural logarithm of 2x. We choose our u will be a natural logarithm of 2x. We derivate it, and we have 2 over 2x. We simplify it, and we have 1 over x. Then we have our dv will be x to the 3. We integrate it, and easily we have x to the 4 over 4. We mix all of this, u times v, minus integral of v times du. This one is already ready, and we have this part. We take out the 4, and we integrate this part, x to the 3. And the integral of this part is already here, x to the 4 over 4. So we mix it, and we have x to the 4 over 16 plus c, and we're done.
Hi, so we have example 3 now, and this is a tricky example, and you'll see why. So first, I grab my u, that it's going to be e to minus x. Then we derivate it, and we have x minus e to x, and we grab cosine of x as our dv, and we integrate it, and we have sine of x. Then we mix our parts, and it's going to be u times v, e times sine of x. And then we have minus integral of v times du. So notice we got this integral and it's as difficult as this one. So and then I have also two variables, so I have to iterate, and I did that here. I mixed my ingredients, and notice I have the original function.
So here it's gonna be another part of the topic that is called cyclic integration, and it goes like this. It's really simple. You just gotta isolate the part that we got in the initial function. So if we put here that this was the process of integrating this whole function, the product. So we isolate this part, take it to the other side of the equation, and we have here that it's a 1, it's invisible 1, and here it's a minus, so we take it and it's a plus, so it's gonna be 1 plus 1, 2. It's gonna be 2 of the initial function, like this. I'm gonna erase a little bit this. And then we have this whole part that we got in the beginning, in the process of the first iteration. And we have to isolate these two to only have the result for the function that we wanted to obtain in the first place. So we take the 2 by isolating it to the next part. So I just don't want to write again everything down. It would be like this. Over 2. So we have the 2 here. It's no longer needed here. And this will be our final solution.
Plus.
Ah, yeah.